Hello, it's James from xrobots.co.uk. This is part 35 of my Avengers Age of Ultron Iron Man Hulkbuster inspired suit, which I've been building for over a year. This is actually a costume that you can climb into, unlock all the joints, go for a walk around, and when you're bored, lock up the joints again, climb out and leave it standing there like it is now. Lots of these pieces are animatronic, which I'll be coming on to in some of the episodes coming up. Last time I worked on the mechatronic arms, which are mechatronic from the elbow down. So there's a joystick that operates those in the upper arm for the elbow movement, the hand gripping, and the weapons which pop out of the shoulder and are concealed in the cuff there with a piece of animatronics. So we've still got lights and sounds and a lot of that build to do. We've still got lots of panels to put on. All of these black parts are 3D printed, and the underlying frame is actually wood. And I've used sheet material to do these skins made of floor mats and foam board. So we're going to revisit the helmet today. I did some work on this in a couple of episodes before, but as I've built out the suit and also watched the actual movie to see how that helmet folds away, I think we need a bit of a different design. My t-shirt this week is my Marvel Collector Corps t-shirt, which came in my Marvel Collector Corps boxing along with the mini Hulkbuster pop. So scroll back in my channel to see me unboxing that and see what else came in the box. Here's the helmet I did before, which is entirely 3D printed. And the aim was that this section was going to flip back on a mechanism. The sides were going to hinge away around the back, and then the faceplate was going to drop down into the body. And basically that's how it was going to assemble. These parts are quite heavy. They were printed in PLA and they're in about 10% infill, but they are quite thick parts. So they're not too bad, but it's quite a lot to hinge away. And I think having made the other parts in a 3D printed frame and then stuck foam on, I'd quite like to redesign the helmet, or at least use this sort of design and, you know, make it a bit lighter and a bit easier to hinge away, not to mention the weight building up on my shoulders as we go. This is the mechanism that was going to sort of hinge those. So I had these hinge pieces here which were going to start at the front and hinge backwards. And then I've got this carriage that runs to hinge the front up and down. This is a bit wobbly and it needed some more reinforcement, but essentially that was going to be what caused everything to open, and of course the faceplate would drop down into the body. But I'm not totally sure this is actually the right proportion now I've built out the rest of the suit. And yeah, it's a bit kludgy, and it's not really how the helmet hinges away anyway in the movie. So here is a bootleg Hulkbuster figure which I bought on eBay from China for not very much money. Basically what seems to happen in the movie, in fact this one does actually hinge open, it's almost what happens, and it seems to invisibly disappear behind the suit, which of course is impossible. But basically what happens is these side pieces sort of hinge outwards and lock in. This piece disappears into the faceplate, and the faceplate disappears into the helmet, and then the helmet kind of disappears behind. So we can do all of that apart from the disappearing behind magically, because there's really nowhere for it to fold up to. But we can make the helmet lift up, and in fact it wouldn't just hinge, it actually sort of come up and over basically, a bit like the faceplate on a normal Iron Man helmet. We can make the faceplate disappear into that hopefully. The very end brim may or may not do anything, and then we can definitely make these side panels hinge in and outwards, so we can have almost all of the motion. You'll notice that the helmet is quite actually tall and pointy. This is not quite the right scale, but it's getting there, and the one I designed before was actually half a sphere, so, or at least a quarter of a sphere, but in profile it was a hemisphere, which is pretty much the wrong shape. So first of all I'm going to 3D print a simple shape so we can offer it up to the suit and see what it looks like. I got the body down and put it on the workmate so I can work on the head without the ceiling being in the way. So I've printed my hoop out, and now that's kind of the first rung on the ladder to working out how this mechanism works. So I sat down for several days trying to plan it all, and I realised I couldn't plan it, so I've done this very simple piece first, and we can roughly work out where the top of the head is going to be, which I think is about there. And that fits quite nicely with the other mechanism that I've put on for these opening shoulder pods. Check out the episode a couple of episodes ago to have a look at how that works. And obviously we've got these weapons that pop out. But we need to avoid that, but that's fine. So we can have this hinged mechanism to the wooden chassis. And I think it's just going to have two arms which kind of hinge it back like this. And depending on where we put them, we can get different angles. Obviously, if we made them very short, it would do this, which is no good. So we actually need to hinge that up and right backwards. So I think those arms need to come right to the back. And then obviously the faceplate is on the front of here, and that will hinge up inside as the helmet goes back. And then the two side pieces will flip in and out to make up that sort of front where the sort of jaw line is. So I think this can go quite far forward, and this is basically the top of the head in profile. I think about that height, I think that's about where it needs to be, not much higher than the shoulders, but I think that's roughly the right sort of contour. So I'll get the next piece printed, and then once I've got that hinge, we can work on the actual faceplate hinge, and then hopefully it becomes clearer what I'm trying to achieve. So those parts are the two arms and the back bracket at the back, which will bolt on so it can be removed. And obviously this allows this thing to hinge kind of backwards like this. So what we need to do is put some stoppers in that hold it at the right height, which I think is about there. And then we need to think about how the next stage folds into that. Here they are. I've added these pieces, which I've just screwed on. So now that comes down to the right height. And we've still got space on the inner faces to put a hinge on, which basically hinges the faceplate in and out. The faceplate's quite a bit narrower than the helmet. It doesn't come out to the full size. So that's what these faces are for here. Obviously I should have designed this all in CAD and done it in one piece, but I feel much more comfortable doing it as I go and adding bits on. And of course all the pieces are made of ABS, which is the plastic Lego is made from. So we can make solvent welds with acetone, as I have with these other big pieces, so that we can just stick on more and more pieces. And that's quite a good way to visualise it. Here's the CAD for what we've got so far. So the blue parts are the parts I've already printed, and the next part is going to be this green part and the red blocks there, which are just going to fix on, as I say, onto the initial bit of the mechanism. And obviously that's going to hinge out on the holes through the red blocks and the green part, of course, which will be the faceplate hinge. So not much to it, but obviously that's going to then fold into the helmet, and the helmet will hinge back at the same time so it doesn't hit me in the face. So we get those printed, and then that's basically the basis for the core mechanics, so then we can start planning the detail. Here it is. So we've got this piece that now hinges out, which the faceplate will be mounted on. It may be that it's mounted like this, or this may be slightly higher up, so it's just below the eyes. Haven't really decided. Obviously this folds up inside the helmet, and this will sort of fold out as it comes down, like so. So mounted onto these pieces will be the little bits that hinge in and out at the sides to make up the rest of the jaw, and they may be on 4-bar links, so they actually move in this sort of motion, a bit like an Iron Man faceplate. And obviously this will then fit into the helmet, and if you can imagine that being one complete dome. So the next thing to think about is how that gets actuated and how I'm going to actually make that faceplate. I found this acrylic dome, which I used before to form the shoulder bells and things by stretching foam over them with heat. And this is actually an R2-D2 sort of sized dome. It's 45 centimetres in diameter. And the plan will be again to form foam and sheet material over it by heating it and stretching it over, so that I can make the main pieces for this. And this cunningly fits exactly on the hoop. And it'll sit about there. Obviously mine will be slightly thicker because it'll be made of foam and multiple layers, the same as the other bits of armour. But that's a rough sort of size to see how that's going to look. And you'll notice that cunningly the faceplate hinge fits right in that contour as well. In fact, it's kind of a finger distance behind, so that means the faceplate is correctly recessed for the rest of the profile. So I've added some levers to the back here, which are these, so that I can hinge this back, and the idea is I'm going to put bungee cord on the back here to counterbalance the weight of the helmet. I've also made these cams, which are basically cams with pulleys on, and the aim was that once the counterbalancing is in place, these can just fit in each side to rotate to lift this, and that could be with pull cords that come down each side, which could go to a motor that winches them, or however, a bit like the way I did the knee joints with the pull strings that pull the latches in and out. But first of all, I need to get an idea of the weight that's going to be on here, so let's try and form up some of those sections. I'm going to use my vacuum forming setup, which I've got here, and if you look back through the last part 4 of my BB-8 project, I actually used this to make the head. What I've got here is actually a wooden box lined with foil and a heater in the bottom, and it's a quartz patio heater that only heats what it shines on, so it uses infrared light rather than heating up the air, and the foil basically allows that light to refract all the way around and diffuse onto a sheet of plastic that's held in this frame. And normally I'd go and vacuum form that down onto the table there by sucking the air through the holes with a Dyson, and that would form over the buck or the mould. But in fact, what I'm going to do is form over this dome. The dome is much bigger than the table and the frame, so essentially I don't actually need to vacuum down though, because it's just a dome, there's no recesses in it. So I can basically just put the plastic in the frame and press it down as far as it goes, and hopefully we can make various dome shapes we can then cut the contours out of to make the helmet. So I've got some sheets of plastic there which are 1/2 metre square, and I'm also going to try and do this with foam floor mats as well, so we'll see how that goes. Okay, my heater's heating up and you can see that light sort of diffusing around the foil, so we should get a constant heat over the whole surface, which is one of the main issues with vacuum forming and generally thermoforming, to basically heat that sheet evenly. So let's put the plastic on and then we'll leave it for about 3 minutes. And then we should be able to go and form it over the dome. Just set off a stopwatch on my phone. This has been about 1 minute 20. You can see that plastic's quite soft. Give it a bit longer and then we'll try and make the form. Alright, that seems just about ready, so we're going to kill the heater and squash this over here. I'll push it down as tight as I can, but obviously it doesn't quite reach the bed for vacuuming unfortunately with this dome, but we have got a substantial amount of dome there formed in the plastic. And this is, I think it's 1.5mm HIPS, which is high impact polystyrene sheet. I haven't tried forming ABS or other types of plastic, but this works pretty well. Black plastic takes slightly less time because it absorbs the heat better, of course. So I'll just leave that to cool down for a bit. Yeah, that seems to be it. There we go, and we've got one big plastic bulge. So we'll do the others, and then obviously what we'll do is cut out contours from this, and they'll all be the same sort of contour for the round of the helmet. So I've formed up 3 of these, I don't know if you can just see them there. So we've got 3 white domes, and those are going to make up the main head contours, and we'll do something else for the faceplate. But now it's time to try some foam, which of course will be under that in layers. So let's just take the floor mat, which I've cut down to fit in the frame. Now I've no idea what's going to happen here, or whether it's going to burst into flames or what's going to happen, so I have to be quite careful. And the door's open so I can throw it outside if worst comes to worst. Alright, so we'll start the clock and see what happens, I guess. Starting to dip, so it's definitely taking the heat. Okay, I had to stop it, it's actually burning and smoke is coming out, so I'm going to still try and do it anyway, but basically turn it over and keep heating it without burning it, hopefully. Hopefully all my smoke alarms won't go off. Maybe I'll hold it a bit higher. Normally do this with a hot air gun, which of course just puts hot air on it. And that works quite well. Yeah, I can see it's changed the surface quite a bit there. It's definitely singed it. So I think I could probably press that over right now. It's only had not too long. Let's give it one final burst, see what happens. It's pulled out of the frame as you'd expect, but let's try this. Obviously the foam retains its heat a lot longer. So I've got a kind of dome piece there. I think that's probably going to be okay to use. And then we'll have to cut slits for the rest. I've put a couple of extra bits in the assembly here, mainly this red piece which is split in two halves for printing, and this green piece which attached to the levered front of the helmet essentially that lifts up. And that obviously forms the back of the helmet, so I can put my bits of foam and plastic over that and that will give it some support into the back. Obviously my assembly here is totally square, whereas in reality the helmet is going to be round at the bottom, but obviously we can only do so much and you're not going to see the back much anyway. Hopefully those levers are going to be covered by the back of the suit. That's something we have to revisit at some point, but obviously from a front view it's mostly going to look like a dome. Right, a heat wave has hit the UK today and it's really hot up here. I'm really glad I did this forming actually yesterday, and I pretty much sort of do a little bit of these projects every day, and I spend the entire 2 weeks making a Hulkbuster video for instance, and it's uploaded just in time for Tuesday. Anyway, here we go. So this is the foam piece. Probably going to make some more of these or just shape the foam by hand over the dome with a hot air gun in smaller pieces. And if you can imagine that being spread over the back of the head as the main layer there, which is going to make the main form of the head, probably like several pieces cut out and interlocked. So that's the main structure. Then we've got our 3 hips pieces that we formed, which have come out quite well, and those again are going to be cut up a piece from each one. So we'll have one for the very top of the head with the widow's peak on, and then we'll have 2 at the sides which make up that kind of dome all the way around. And again we're going to cut those and either layer them on stepped bits of foam, or we're going to have slits between them that basically make up the lines of the helmet, and we can stick 3D printed bits and other material on top. I also did another one, which is this one, which is far more rigid. It's 3mm foam PVC board, and that is going to be the faceplate. So that is going to stick straight on that faceplate mechanism, and there's enough gap there. We've got a 10mm gap and a 3mm bit of foam. We can still line it with some thicker foam around the edges, but basically that will make up quite a rigid faceplate cut to the shape of the faceplate from this, and that will give us the place obviously where we can cut the eyes and mount electronics and things. And that'll also be seen from the inside at the back of the helmet when the faceplate is flipped up and the helmet is open, so we need to put some details on the inside of that that actually looks like something and not just a ton of hot glue. I've been thinking about marking out that panel for the faceplate, and I was looking again at the 3D printed one I did, which I think is about the right proportions in terms of where the eyes go at least and where the front is. So if you can imagine that on there, obviously it's too thick to fold in, but I think that's about where I want it. So I'm actually going to use this to draw around to make the template on that curved piece of foam PVC board. So here are these parts laid onto the foam PVC curve I did. They fit quite well. Obviously the faceplate is only up to this region and the widow's peak will come forward, and obviously it will be wider as well. There's sort of a square edge on the faceplate I think, but it's actually going to be overlapped by the rest of the helmet with those other sections. So in fact the edges don't matter too much as long as it still will retract into the helmet. The actual contour of that faceplate will be made up by the overlapping sections and the pieces that fold in from the side. So I can pretty much just cut this piece off and attempt to work out where the eyes go, and then basically roughly cut a square on the side and see if that retracts into the rest of the helmet. So I need to mark out a line on the bottom here which this will align with, and then that contour will continue to the sides of the helmet. So what I was going to do was take this string and put a pen in the loop, and I've marked the middle on the sheet at the back here, and I was just going to hold the string and draw a line, but as you can see the string curves onto the sheet there, so we won't get an accurate line and it will change length depending on which direction we're going in. So instead I'm going to put this back against the workmate and put the string up here and just hold it in the middle, and then I can move my pen across to draw a line hopefully neatly across in the middle there. So let's just give that a go. Just need to get the pen right in there, make sure that's in the middle, and then I can draw a nice smooth line across here. There we go. So that will be the very bottom of the faceplate. And then I can align this to it and work out where the eyes and the other features go. So this is approximately what I think it should look like. I've drawn around those other printed parts and drawn in the eyes there. So I'm not actually going to cut these out yet, but I have obviously got the bottom line there and also drew a couple on the top, and I'm going to cut the inner one. And then we can offer that up to the suit and see how it looks. Obviously there are other features on the suit. We've got that very thick rim around the bottom, which will be stuck on the outside, and other features, and of course we can make more of these and layer up the parts to give the detail, or we could stick on 3D printed parts. There we go, starting to take shape. I'm going to use one of my cut edges as a template to curve off the sides here to get rid of those pieces. So I'm just going to measure in at a point from each of these corners on each side, and then align this, draw a line and cut along it to give me a nice curve. Alright, here it is. So I've cut quite a bit off it. It's still slightly too big. And it's going to be squashed more, well, sideways like this, so that it fits inside. And of course the internal contour is going to be, this was moulded on essentially something that fits on the outside, which is why it needs to be squashed in, so the internal contour should be less. But basically that will flip inside and fold away, and then it will fold out. And I need to take some more off these corners, because at the moment that doesn't quite work. It wants to go on the outside, and it needs to be squashed in, probably with another 3D printed frame part in the back. Which, you know, forms a T-shape or something off this piece, so that that neatly slides inside like so. And then we need to consider the outside, but I'm not going to cut any more off this thing or cut the eyes out till I've actually made some more of the outside. So basically that's all I'm doing for now, but you get the idea of how this is going to work. And this piece is really lightweight because it's made of foam PVC board. I really want to think about this some more before I carry on with those other head pieces, and I need to experiment probably with some tin foil like I did before to make contours by mashing it into shape to make those pieces on the outside of the head, and basically where that widow's peak comes and how it overlaps that faceplate. I've already made one helmet and one mechanism which I've had to put to one side, so I don't want to do that again. So I'm going to carry on with that in a future episode. So don't forget to subscribe to my channel for more updates on this project, of which there'll be many, and all my other projects, including my 3D printed life-size R2-D2 style droid, my BB-8 droid, and my 3D printed alien suit. Also don't forget to check out my Patreon campaign at patreon.com/xrobots if you'd like to help support this channel. All my projects are funded by my followers, basically so I can carry on making awesome content. Thanks for watching.